Thank you, everybody, for joining us today. We have got an interesting session and a lot of ground to cover. My name is Whit Moses. I'm a senior PMM here at Tonic AI, and I work really closely with Adam on our Tonic Textual product, which is focused on operationalizing unstructured data for AI and ML use cases. Adam Kamer, he is one of our co-founders and head of engineering. I'd also argue that he is one of the brains behind Tonic Textual. He spends most of his waking hours trying to solve for the problem that we're here to discuss today, which is how to best leverage unstructured data that typically appears in the form of text. This can be transcripts, PDFs, written notes, any number of assets, all of which are full of important information and context. But how do we take these internal sources of data and leverage them across AI and ML initiatives in a way that protects privacy and by proxy adheres to compliance requirements while still preserving the useful context contained within? So I'll hand off the mic in just a moment, and Adam will drill into this opportunity and challenge a bit deeper. We'll be providing a quick demo of Tonic Textual, which offers an approach to tackle this effort at scale. And then we have a quick case study to share of a Tonic Textual customer who's building out their AI capabilities with the assistance of Textual, followed by some general guidelines around establishing and maintaining compliance for these types of initiatives. So with that, I will hand the mic to Adam to get us going.
Thank you, Whit. All right, let's go to that first slide. Excellent. Okay, so let me first frame the kind of opportunity / challenge that I think a lot of the folks that have joined the call today are facing. Models now are trained on a large percentage of publicly available data, and it's now the privately held data that sits behind enterprise and company firewalls that's your main competitive advantage. But this data itself holds a lot of value, but it can be very hard to extract that value. And how do we extract value from our unstructured data? It is kind of like the driving force and reason for existence of Tonic Textual. You have private data, it's highly valuable, but you're kind of blocked from using it for a myriad of reasons. So let's talk about what some of those challenges of accessing your unstructured data are. Next slide, please. Excellent. So the challenges. You can just pull up all the bullet points, so that's fine. Okay, so there's kind of two main challenges. The first is unstructured data is very challenging to deal with, right? Like if you're talking about data sitting in a CSV or in a database table, it's relatively straightforward. It's like, oh, okay, that column is names, that column is zip codes, that column is SSNs. You kind of know what everything is. But with unstructured data, think things like PDF invoices or legal contracts in a Word document, or even a recorded audio conversation or handwritten medical notes. Actually extracting out and teasing out what's important in those types of documents or files is a real challenge. And it takes a contextual understanding of what's going on within the document to really understand anything. But before you even kind of start that challenge of how do we extract information, there's this elephant in the room, which is risk, privacy, and compliance. As an example of that, let's say I'm in the healthcare space. I have a bunch of medical notes from doctor-patient interactions. These would be notes that a doctor writes after talking with a patient and about their, encounter for that day, right? Within these notes is a lot of useful information, both about patients in general and the population at large. But of course, you can't just go take something like a collection of medical notes or legal contracts or financial statements, what have you, and just go train a model on this type of data. The data itself is highly sensitive. It contains a lot of customer information, and there's laws and frameworks in place that kind of prevent you from doing this. I'm sure many folks on the call are probably in the healthcare space, so a good example for them would be HIPAA. HIPAA, would expressly forbid you from taking real patient data and then training models on it, because all of a sudden your patient information is embedded into the weights of your model. So before we even deal with the extraction part and processing of the unstructured data, we have to first answer this question of, okay, well, how are we going to even use the data if we could extract it? It's all highly confidential. Legally, we can't go train models on it as is. So what do we do? Okay, let's move to the next slide. Thank you. And folks, I know people can't unmute themselves in a webinar to ask questions. So we do have a chat, but also a Q&A feature. So if you go to the bottom of your screen, you'll see that Q&A button. And you're welcome to go put in questions that I might answer them live as I'm going through the presentation. But if not, I promise to answer them at the end of the presentation or at the end of the demo. Okay. Okay, excellent. So let's talk about Textual's approach to how we solve this problem. Textual is a set of technologies presented as an entire platform or solution that can both identify and then create new sensitive values in unstructured text. And there's kind of two steps to this process. The first is the identification of sensitive information. So, you give Textual a raw text document of a doctor-patient interaction or of a financial statement or something sensitive. Textual will identify within the document or within the file all of the different entities that are potentially sensitive. So identification is half the puzzle. The other half is, okay, we've identified these entities. What do we do with them? How can we transform them so that we're preserving the privacy of our customers, but we're also creating new data that is useful for your end goal, whether it's to train models or to generate, mirrored environments and staging with de-identified data that is insensitive or what have you. Okay, so how do we, so Textual both does the identification and then the redaction or synthesis of your unstructured data. Once that's done, you can then leverage this new sanitized data for analysis, for inference, for training, or even for test and development. Okay. Speaking of the approach, let me give a quick 5-minute, maybe 10-minute demo of how the product works. And again, as questions come in to the Q&A part, I'll do my best to get them answered. All right, and now I am going to share my screen. Let me very quickly log into the product.
Okay, great. And I'll be keeping my eye on the chat while you're sharing your screen. And if we get a question and it seems like a natural moment to address it, I may come off mic for just a moment, Adam.
Yeah, perfectly fine. I won't be paying attention so much as I'm screen sharing. All right. All right. The standard question that one asks. Can everyone see my screen? Excellent. Okay. All right, great. So here I am in the Textual product. I'm using this today from textual.tonic.ai. If you could post that URL in the chat, folks are welcome to go there. They can go, very quickly create an account. And if you wanted to, you could actually follow along with the demo today. We have a free tier that once you log in, you can take full advantage of the product. Of course, this product is hosted in our cloud. Many of our larger enterprise customers can't use our cloud because they can't send their sensitive information beyond their networks. So for those customers, Textual is also available as a self-hosted solution. It's packaged up as a set of Docker containers. You can deploy them on your local, on your internal networks. And then the same experience that you get in our cloud, you have on your prem, whether it's in your own data center or in a public cloud like AWS or Azure. Okay, so when you first log in, you're taken to this screen here. This is a playground. This is where you can type text in or paste it in, and then get a better understanding of how our models will identify sensitive information. So here I could start typing, but I'm just going to use one of our kind of pre-canned samples at the bottom so you can understand what it looks like. Okay, so I've entered in this transcript on the left. It's a phone conversation of someone trying to reschedule an appointment. The model highlights in yellow all of the entities that we're flagging as being sensitive. And on the right, we're giving you an idea of what it would look like if we redacted those entities. So for example, City Health Clinic is being flagged as an organization, Sarah as a name given or a first name, and then it just continues down the page. Of course, redaction is only one side of what we can do. We can also synthesize new documents. So let's start synthesizing specific entities. I might choose to synthesize just first and last names. okay, as an example. So now you can see that Emily is no longer being replaced with name given, it's being replaced with Judson. And in fact, there's multiple instances of Emily here, Emily going to Judson again. So when we synthesize new data, we do it in a way to preserve the semantics of the underlying original document. Emily will always go to Judson, just like Lemmy, the last name here and here, will always go to Sotelo. Notice that here Lemmy is all capitalized, and here Sotelo is all capitalized. When we synthesize, we try to always preserve the format and function of the original entity. So if it's all capitalized originally, it'll all be all capitalized in output. If we're dealing with date times, we always ensure that the transformed dates that we synthesize adheres to the original date format, even if it's a very complex non-standard date format, like perhaps one that you would find if you were talking to customer support on the phone trying to schedule a service date. Okay, so this playground, though, it's just for fun, right? You go here, you type in text, you see how things work. No one is doing serious work in the product on this playground. Most of our customers, they come to us, they're processing, hundreds of millions of words of data a week, right? You're not going to accomplish that by copying and pasting into this input box. So a lot of work is done via our SDK. In fact, if I go down here and click show code, you can actually copy this Python snippet, run it in a Jupyter notebook or in a Python program somewhere, and you'll get the same result as you would on the playground. If you don't want to use Python, you can accomplish this also via our REST API, and we'll show you a curl snippet of how to do so over here. So you can go implement this function call in whatever language you like. For now, though, let's just go with Python. I'm going to copy out this call here. I'll quickly go to my Jupyter notebook. I'll paste it in right there, and I'm going to run it. And you can see what we do. So now, the response that you get actually has a lot more information than just what the playground is showing, right? In the actual response that you get back when using our API or SDK, you of course get your original text back. Then you get the redacted text. Notice here that we're not replacing entities with actual just like labels like organization or name given. It's a bit more complex than that. So originally we had City Health Clinic flagged as an organization. When it's redacted, it's replaced with organization underscore a unique token. That token is unique to City Health Clinic. And in fact, the token is just a piece of ciphertext, which can be reversed to get back the original value if needed. Additionally, if you guys remember from the configuration I set up, we chose to synthesize first and last names. So you can see here, originally it's Sarah, and now it's Alicia. Now, the last thing I'll show is this list of de-identify results. This is the list of all of the entities that we find within your data. Okay, so for example, we find City Health Clinic. It's being flagged as an organization, and it's found starting at position 28 and ending at position 46 in the original string. So, if I go here and I start counting from 0 all the way to 28, I'll end up here. And if I continue counting to 46, I'll land right there. So the information that you get in these de-identify results is the actual per entity level information on what we're finding. And for a lot of workflows that our customers build on top of our models, the information here is actually super relevant. Oftentimes, what's found here can be more important than the actual redacted text string. A lot of customers just need the list of entities to feed, downstream processes. Okay, so what I haven't shown yet is how we work with files. So let me show that briefly as well. And I could process files via our Python SDK or via the API as well. But for the demo, I kind of want to show like how files look originally and after processing. And it's a lot easier to do that in the UI. So I'm actually going to switch back to the UI momentarily. But everything I do, you can also do programmatically. Great. So I've gone ahead already and created a data set. A data set is just a collection of files. If I go up here, I can see all of my data sets, and then I can create new ones. Once I create a data set, I upload files to the data set, and then all of those files will get redacted or synthesized in the same way. With the data set, it's a file in and then a file out. As an example, if you give me a PDF, I'll return to you a redacted or synthetic PDF. And of course, we work with many file types beyond PDF. To name a few, we work with Word documents, Excel files, various image formats, PDFs, also a myriad of audio and video files as well. But for today, we find PDFs to be most relevant to our customers. So let's focus on a PDF. I've already gone ahead and uploaded a PDF. This is a This is a medical form that I found online from the state of California and filled it out with some bogus information. And then I run it through the system so everyone can see what to expect. I click on the PDF to view it. And you can see that on the left-hand side, we show the original PDF. And then we highlight in yellow everything that we find that's sensitive. And on the right, we show you this redacted view. I need to make one change that I forgot to make first. Let me save that, close, and let's go back to that PDF. Sorry about that. So we're highlighting all of our sensitive information in yellow. I'm going to point out a few mistakes that have been made, and also a few edits I want to make that aren't mistakes, but that will help improve my desired output. Okay. First observation, we're flagging these organizations, and I know they're organizations because of the tooltip. I don't really care about organizations. I don't consider them sensitive for my current use case. So I'm going to want to disable that. Additionally, we're flagging these checkbox labels, male and female, as being sensitive because they're gender identifiers, which is one of our entity types. Finally, we're flagging numeric values as sensitive, right? A numeric value is basically any numeric value. It doesn't necessarily mean it's a sensitive numeric value. We have other entities that are more specific for that. Think of numeric value as more kind of like a catch-all. So let me disable a few of these entities, and then let's look at the document one more time. So I'm going to disable gender identifier. I'm going to do numeric value. I'm going to do organization. We don't need product. We don't need URLs. I think that's good. Let's go back to the document. Okay, that's looking nice. Let me download the file now. When I go to download it, this is the result that we get. As everyone can see, it's a clean, redacted PDF. Excellent. But oftentimes, redacting isn't exactly what you want, or maybe it's half of what you want, but you also want new PDFs with realistic values in there. So let's show you that. Now, for all of the entities previously that I had set to redaction, I'm going to synthesize. I got one more. We're going to open that PDF one more time. And voila. Now we have a new PDF with realistic values entered. It looks and feels real. The data itself will be consistent. And you can use this for example, testing an ETL pipeline or producing a staging environment with safe PDFs for testing and dev. Or perhaps you're training a new visual layout model or OCR engine, and you need PDFs to actually test on, or to rather train on, excuse me. You can do it here. Okay. With that, I'm going to hand it back to you so that we can talk about some of our customer success stories. And then let's keep going.
Awesome. Let's do it. Let me reshare my screen.
Hey, real quick, Vinay asked a question about how some of the underlying technology works. So Vinay asked, do you use NER or LLMs to detect sensitive entities? So the answer is that we use NER models. We use a Roberta-based model to identify sensitive information within text. There's a few reasons for that. The most relevant is we deal with large amounts of data, and our customers kind of expect to have very fast processing speeds that you really couldn't support with like large language model style approaches. Roberta models are cheap to operate. They can run on far less powerful GPUs, and they're blazingly fast. On a very modest GPU setup with perhaps something like an NVIDIA A10, you can process tens of thousands of words per second. And of course, the solution can scale both horizontally and vertically to kind of reach any word throughput you need at a fraction the cost of what it would be to use an LLM. So Vinay, hopefully that answers your question.
Yeah, and we got another question from Narendra. He says, in the PDF example that you showed, can the tool distinguish between prescriber and patient info and redact patient info only?
That's interesting. There are ways that you can do if we're talking about like PDF form style data. There are ways that can be accomplished. Because the form structure itself can provide hints as to like, okay, the name here, like the form label might be patient name, whereas elsewhere it could be provider name, and that can provide us insights that can help us kind of choose how we redact or synthesize. If we're talking about raw text, that can be a bit more challenging, but we do have approaches that we can use there. We have a set of techniques we use that I didn't really plan on speaking to them today because they're a bit more in the weeds. But we have a set of entity linking models that can be used to help make decisions like that, where it's like, okay, that name relates to the doctor or to the patient, etc. Um, Tom asked another question. Is it possible to show all integers but still redact the weight? Tom, you have a tremendous amount of control over how we redact or how we identify entities. I didn't get into it, but we have these concepts of both custom entities. These are entities that you define that then our system can then go and look for. We also support the ability to edit our existing entity finders by adding logic that can exclude or automatically include certain pieces of text and flag it as a given entity. So for you, Tom, I think the answer is yes. We could, redact the weight but leave other integers alone. Okay. Um, uh, Benny, we're getting a lot of questions, but we only have 5 minutes. How about you keep going and I'll answer the questions in the chat, like by responding.
That sounds great. And quick apologies to everyone about my Zoom deficiencies. I shared the link to the textual page just to the Adam and myself. So resharing here in the chat so that everybody has access to it. But I'm excited to talk about a Tonic Textual customer, Wealthy. Hopefully everyone can see my screen. And this is an organization that is currently using textual as part of their AI strategy and product development. So for those of you who aren't familiar, Wealthy is a digital healthcare company focused on providing support across the entire healthcare spectrum. They have services for families, employers, insurance companies. And as such, their platform creates and leverages vast amounts of personal health information, or PHI, all of which is subject to very strict compliance requirements under HIPAA, which is the de facto regulation governing the management of healthcare data in the United States. So, being a digitally native business with an emphasis on building and embracing cutting edge technologies in order to optimize experiences for patients and businesses, AI has historically been a fixture on Wealthy's product roadmap. And so that means that even before they engaged with Tonic, they were exploring many different options so that they could pursue the development of new features powered by AI and leverage what is a relative mountain of valuable of a mountain of valuable unstructured data, and that comes in the form of free text messages sent between members and healthcare teams. And that contains powerful information that can be used for model training and feature development. So prior to Tonic, the team at Wealthy took a few different approaches, ranging from generating a bunch of fake data on their own and also with a faker library. But the result was buggy models that were trained on data that was less than realistic. And likewise, the team was also wasting cycles leveraging this fake data, which were creating performance issues once those features hit production. So that combination of pain is ultimately what led them to seek out a vendor that could help them de-identify the PHI within these sensitive data sets while preserving the context of the data to ensure that what they were taking into production was in fact true to life. So, and taking into production and also training their models on. So after partnering with Tonic, they saw bugs and false flags literally cut in half, accelerated workflows as they were able to reduce wasted development cycles and automate the de-identification of these data sets. And ultimately, they were unblocked on the development of their AI features, which were previously being stalled by this unreliable data. So this slide speaks for itself, but there's a lot more detail, and we'll include the full case study in our follow-up. And that really digs into how Wealthy was able to leverage Tonic to move quickly, leverage their sensitive internal data while still protecting privacy and remaining HIPAA compliant. I'm going to speed through this next one, but on that note, a quick conversation around navigating the compliance landscape while leveraging sensitive data. Since we just talked about a company in the healthcare industry, I'll speak to a few approaches specific to that world. However, this is also relevant for any organization that uses PII whether you're a bank trying to train on customer service calls containing account numbers, or even just a business with an ethos and emphasis on protecting customer information and preserving privacy. However, for healthcare companies specifically, like I said, HIPAA is the regulatory framework which dictates how this data can be handled. And there are multiple approaches to ensure compliance. Folks may have heard of Safe Harbor, which involves essentially the pure redaction of sensitive information. However, with this approach, you're obviously sacrificing the context within those redacted entities, which may contain information that's pertinent downstream. So this dilemma is ultimately part of the impetus as to why Tonic Textual was built, which leads us to the next strategy, which would be engaging with an expert determination vendor that is able to validate and certify that PII and PHI has been eliminated and in fact replaced when synthesis is a part of that strategy. So Tonic Textual was built with the expert determination process in mind, both in terms of being able to quickly identify and replace sensitive entities. And like Adam mentioned, this is across multiple different file formats and leveraging developer tools, which allow this to happen at scale with massive volumes of data. But also in a way that makes it easy to export and share with those teams. And it's just worth calling out that we have a really long track record of working with expert determination vendors. It is something that we do really well. We have some great testimonials of companies that have been succeeded in this process. And if it's something that you want to talk more about, we definitely encourage you to book a demo because it's something that we can speak about and share more detail on. And last but not least, we will also be sharing another asset. It's what we're calling a fine-tuning playbook. It includes a Jupyter notebook and a sample data set where you can essentially take what Adam demoed on earlier today and get your hands dirty and try it for yourself. So keep an eye out for that. We'll be sharing it in our follow-up email. And with that, we're right at the bottom of the hour. So checking on the chat, any last minute questions we want to get answered, Adam?
Roy is asking if the system can be used in real time to redact logs. And Roy, the answer is yes. Using the Python library or the REST API, you can essentially just send messages to either and then get back redacted responses, in a matter of very quickly. Just think of them as normal web requests, maybe 100 milliseconds, maybe a little more of response time is needed. So it's very quick. Note though, if you begin using our SDK, that depending on your type of log, you might want to use our redact function, which I demoed, or the redact JSON function if the logs are actually JSON logs already. And if you have any questions, just reach out and we can assist you and get you set up. All right, Whit, I think that's it. Great questions today. I hope everyone enjoyed themselves.
Thanks a lot, folks. Keep an eye out. We'll be following up, sharing the recording of today's session, as well as all of the assets mentioned. Hope that this was helpful and reach out, schedule a demo. If you're interested in digging in a little bit deeper, we'd love to hear from you.
Awesome. Thanks, everybody.